Welcome to this explainer. Picture this. You're up in the mountains. It's a perfectly crisp, sunny day, right? The air is fresh, the scenery is absolutely breathtaking. But then, literally out of nowhere, the sky just turns violent. We're talking a catastrophic deluge of water dropping from the heavens in a matter of minutes. It transforms this serene landscape into a deadly raging torrent. So how does that even happen so fast? What triggers such a catastrophic shift? Well, today, we're dissecting the anatomy of this disaster to figure out exactly how these terrifying events unfold. Okay, let's just dive right in. What exactly are we dealing with here? A cloudburst is essentially a sudden, extreme, and highly localized downpour that drops just massive volumes of water. And usually, it happens in under an hour. Now, I really want to emphasize that part, under an hour. This isn't your standard rainy day drizzle that just kind of lingers all afternoon. No way. This is a hyper-concentrated, incredibly fast-moving threat. It's that brevity, combined with the sheer, crushing volume of water, that makes it so terrifyingly dangerous. To really wrap our heads around that intensity, just look at this shocking number, 100 millimeters. That is nearly 4 inches of rain. Now, to put that into perspective, 4 inches over an entire week, that's a pretty wet week. But 4 inches falling in a single hour, or even less, that is an absolute catastrophe. It really highlights the sheer intensity of the water dumped. It's practically a solid wall of water dropping from the sky all at once. And sadly, it's the exact kind of sudden, immense volume that has devastated real-world places like Leh and Uttarakhand, literally wiping out entire communities and infrastructure in mere minutes.
So, what's the actual culprit behind this atmospheric water bomb? Well, the answer lies right in the terrain itself. Steep, mountainous terrain isn't just a pretty backdrop for these events. It's the active ingredient. It's what creates these ticking water bombs. To really get a grip on cloudbursts, we've got to look closely at how mountain weather actually causes rain in the first place, and how it manipulates the atmosphere into these violent extremes.
Right, so this whole process is driven by something called orographic lifting. Here's how mountain weather inherently causes rain. Picture warm, moist air moving steadily across the landscape. Suddenly, bam, it hits a steep mountain. Obviously, it can't go through solid rock, so it's rapidly forced upward by the terrain. And as this air gets pushed higher and higher into the atmosphere, it cools down quickly. Now, cold air just can't hold as much water vapor as warm air can. So all that moisture rapidly condenses, forming these heavy, massive, moisture-laden clouds. This violent upward flow, that is the very engine of mountain weather.
Let's break these meteorological mechanics down a bit more because, honestly, it functions exactly like a giant water bomb. First, that moist air hits the mountain, gets forced up, cools, and condenses. But here is where it gets crazy. You have these strong upward air currents, updrafts, that actually stop the condensing raindrops from falling to the ground. They literally keep the water suspended in mid-air. This lets the droplets combine, grow exceptionally large, and just accumulate massive weight. But then, those powerful upward winds suddenly weaken. They fail. Suddenly, there's no upward air to hold all that moisture up. The structural integrity of the storm just collapses, resulting in a violent deluge over a very, very confined area.
Which brings us to the terrifying moment of the actual burst. Like it says here, the entire volume of moisture drops all at once, resulting in a violent deluge over a very confined geographic area. Because that cloud simply can no longer hold the immense weight of the accumulated water, you get an instantaneous, localized atmospheric collapse. I mean, just imagine the sheer force of thousands of tons of water letting go simultaneously over one specific ridge or valley. It's mind-boggling.
And what do you think happens the exact second all that water hits the ground? Gravity takes over. Remember those steep mountain slopes we just talked about? Well, they instantly turn this highly concentrated deluge into a downhill nightmare. The steep slope causes instant flash floods and triggers massive landslides. The very terrain that created the storm now acts as a high-speed slide for the destruction, carrying water, mud, rocks, the whole shebang, down into the valleys below at just terrifying, uncontrollable speeds.
But you know what makes this phenomenon even more chilling? Its stealthy nature. This is an incredibly unpredictable threat. These events usually only last a few minutes to maybe an hour, and their geographic impact is highly localized. I mean, one valley might be entirely devastated while the next valley over barely sees a single drop of rain. And perhaps most frighteningly of all, they are incredibly difficult to forecast. Even with state-of-the-art modern tools like Doppler radar, their heavy reliance on specific, hyperlocal mountain terrain makes predicting exactly when and where the burst will happen nearly impossible.
Now, if the mountain terrain is our culprit, we've got to look at the accomplice in this mystery. Rising global temperatures are supercharging this already violent cycle. We really have to look at the climate change multiplier because it is fundamentally altering the baseline of these meteorological events, making them not only more frequent, but significantly more destructive. The stark climate math behind this is just staggering. Check this out. For every single 1 degree Celsius rise in global temperature, the atmosphere's capacity to hold moisture increases by about 7%. Think about what that means for our water bomb analogy. Warmer air acts like a much larger sponge. It holds significantly more water, which absolutely supercharges the whole hydrologic cycle. So when those updrafts finally fail, there is simply a lot more water to drop, which fuels much heavier and far more devastating bursts. Furthermore, it isn't just about the sheer volume of water, it's also about the timing. Climate change has severely altered our monsoon cycles and standard weather patterns. We're now seeing disrupted patterns where these massive extreme rainfall events are dropping right after abnormally long dry spells. Now, when a massive cloudburst hits ground that has been baked dry and hard for weeks, the soil just can't absorb the water. It basically acts like concrete. The water runs right off, exponentially increasing the severity and the speed of the resulting flash floods.
Knowing all this, how on earth do we cope? Because these massive, cosmic-scale water bombs cannot be entirely prevented or perfectly predicted, disaster management really comes down to personal survival and readiness. Surviving the deluge is all about knowing your specific risks before the sky goes dark and having a clear, actionable plan in place.
So, the absolutely crucial point here is following these safety and preparedness rules immediately. First off, you absolutely have to avoid vulnerable areas. Please do not camp or build in natural riverbeds, gullies, or narrow mountain valleys. These features act as deadly natural funnels for flash floods when a cloudburst hits. Second, constantly monitor alerts from official meteorological departments so you can track heavy monsoon spells. And third, if you live in a vulnerable hilly area and face incessant heavy rain, you must be willing to temporarily relocate to higher ground right away. Seriously, you cannot wait for the burst to happen to make your move.
Which leaves us with this crucial question to wrap up our explainer today. With unpredictable water bombs constantly being fueled by a warming climate, is your community ready for the next sudden deluge? It's a heavy thing to consider, for sure, but the sheer unpredictability of extreme mountain weather means that the absolute best time to prepare is right now while the sun is still shining. Thank you so much for joining me to break down this incredible natural phenomenon. Keep learning, stay safe out there, and